Hello everyone, welcome back to Automation Agent, your channel for AI-powered automation. Today we have an exciting topic to discuss, the information retrieval pipeline for PDF chat with Automation 360 RE Digital Assistant. In this video, we'll delve into how you can create a chatbot that provides the best answer based on your proprietary content. We'll also explore the tools, the building blocks that makes this possible. So let's get started. So before we dive into the technical details, let's understand the use case. Imagine you have a vast repository of PDF documents and you want a chatbot that can instantly provide you with the most relevant information from those documents. That's where our information retrieval pipeline comes into play. To achieve this, we'll be using two powerful tools, Automation 360 RE Digital Assistant for human bot collaboration and GenAI.net for generative AI and information retrieval pipeline. So now let's break down the building blocks for our information retrieval pipeline. The first building block is text embedding. So this step transforms the text into numerical vectors in a way that captures the semantic relationship between words and documents. Essentially, it helps machines understand and process textual information more effectively. We are going to use OpenAI to generate the text embedding vectors. The next one is our vector database. This is a specialized database designed to store text embedding vectors. It enables the retrieval of the semantically similar text. Think of it as a treasure trove of your knowledge waiting to be accessed. And GenAI.net provides out-of-the-box vector database implementation that can be serialized into a file, VDB file. The next one we have is our information retrieval pipeline. This is the heart of our system. It's a pipeline of semantic search tools that uses vector database to identify the relevant chunk of information. It then employs a query tool to answer the questions based on the context retrieved from the vector database. And finally, we are going to use RE Digital Assistant to plug everything in and provide a good, nice user interface. So RE Digital Assistant is part of Automation 360 platform, and it is provide you kind of a mechanism to orchestrate the bot and the user's input forms through your RE process. It's a bridge that connects your queries to your information retrieval pipeline. Before we get into the nitty-gritty of the information retrieval pipeline, it's important for us to understand the limitation of the language model. The GPT 3.5 model can work with approx 4,000 tokens, which is approximately 3,000 words. So we can't just pass the entire 100-page documents to the language model as context, because this context will be much larger than this 3,000 word limit. So we need to pass only the relevant information as context to the language model. That's where our information retrieval pipeline comes into play. The information retrieval pipeline is a multi-step process that helps us find and use the right pieces of information from a large document. Let's break it down step by step. The first step involved is splitting the PDF text into smaller, more manageable chunks. Think of it as breaking down the information into digestible pieces. But that's not all. We then pass each of these chunks through a vector transformer. We are using OpenAI text embedding, which transforms each chunk into numerical vector. These vectors are representations of the text that captures its semantic meaning. These vectors are then stored in a vector database for our future use. Now let's talk about how this pipeline works when a user has a question. When user question is fed into the system, the magic begins. The system uses the same vector transformer to transform the user input question into the vector representation. It's like turning the question into the language that machine understands. Next, the semantic search tool takes this vectorized user question and searches the vector database to find semantically similar text. Once we have identified the relevant context, we construct a prompt. This prompt combines the user's input question with the retrieved context from the vector database. This is the secret sauce that gives the language model the context it needs and to provide the final output. Now, let's implement a PDF chat system using GenAI.net library and RE Digital Assistance. We have got a massive 109-page document, which is a healthcare plan, and we are going to build a chat system that can answer questions based on the documents. Let's get started. Our first step in this journey is to create a vector database. To do this, we'll use Automation 360 and set up a task bot named CreateVectorDatabase. We begin by splitting the PDF document into separate pages using PDF split document action. Each page will become a separate PDF file neatly organized in a folder of your choice. Once we have these individual pages, we'll pass each of them through a vector transformer powered by GenAI.net. This step is crucial because it transforms text into numerical vectors, making it machine readable. To connect with GenAI.net, we'll use DLL action within Automation 360. We'll open a session, initialize it with the necessary details like language model, API key, log path, and then we'll call the CreateVectorData for semantic search function. This function requires a source, which can be a PDF or text file, or even a folder with such files. We'll also specify the destination, which is the full path of the document output database with a .vdb extension. CreateVectorDatabase function has its inbuilt text splitter. Hence, since we have already split the document using PDF split document action, we set the chunk size higher than the number of characters in each PDF just to avoid the splitting. So for instance, in this case, we are going to put 100,000 number of characters and overlap at 0. With everything in place, we are ready to create the vector database. Running this process results in PDF document being split into 109 PDF files, and the final VDB file is ready. Now that we have our vector database ready, it's time to build our information retrieval pipeline. Our pipeline consists of 3 key steps: initialization, tool creation, and tool execution. The initialization and tool execution steps remain same and consistent for most of the bots that we are building with the GenAI. And this has been explained in our previous video. So I'm not going to spend much time to demonstrate that. I have created a boilerplate code that is ready for this solution pattern. We are going to focus on the tool creation step. We'll use create semantic search tool from the DLL to craft our search tool. It requires a name, description, full path of the vector database, the .vdb file, and max result counts to specify how many results or how many chunks that we want as results. So let's update all the parameters appropriately. Now let's frame our question for the chat. How about what are the maternity services covered in this plan? With this question ready, we update the execution context dictionary with the query and its value. Then we execute the tool with the updated context and the magic happens. When you run the search tool, you'll receive a JSON string in the output. This string contains the text content and references from where the information was extracted. You will notice that the search tool accurately picks up the text chunks from page number 38, where we have the information related to the maternity benefits. And there you have it. So our semantic search tool in action. With max result count set to 2, we receive 2 result items in the JSON output string. Now let's move on to the next tool in our information retrieval pipeline, which is the query tool. This tool will take the information retrieved from the vector database and use it as a context to query the language model with the user's question. This means this query tool will require 2 parameters as input, but there is a problem. In our pipeline, the second and subsequent tools should have only 1 parameter so that the result of the previous tool in the pipeline can automatically be passed to the next tool as input. When you define a prompt template for the query tool, we have a clever naming convention to simplify things. Since the question already comes as an input, we don't need to introduce new parameter. We can use input.question as a parameter so that it can automatically reference the question that is coming from the input. And the other parameter can be left as is, or we can use result dot name of the tool from where it needs to be bound. But in this case, we are going to leave it, say, context. Now with these tools in place, we create our tools pipeline. Remember, our execution context is already set. We just need to update the tool name to reference the pipeline in the execute tool function and execute this bot. And there you have it. When you run it, you will receive the details of the maternity benefits covered in the plan as the output. This completes our query from documents task. And that's the information retrieval pipeline. We'll now explore how to build a digital assistant that allows users to interact with the chatbot seamlessly. Before we jump into the digital assistant or RE Copilot creation, we need to set up the foundation, that is the forms. In Automation Copilot, forms act as interface through which users can input their queries and receive responses. So let's first create the health plan input form, a simple form with a text area where users can input their question. Then we can craft the response form, which features three text areas. The first one to display the previous question, the second records its response, and the third one waits for any follow-up questions. Now let's connect the dot by defining the Automation Copilot process flow. We'll name it Health Plan Process. This flow will integrate our chatbot and these forms into a streamlined interaction. We designate the health plan input form as the starting point of our process. It's the gateway for users to begin their conversation with our digital assistant. Next, we introduce a bot task into the process. Here, we are going to call the bot we created earlier to handle user queries. The right panel automatically populate with the required input values for the bot. We do need to bind these input values with our form elements. So let's bind it. First, we'll bind the question parameter with the request input form, that is the question text. This ensures that bot knows what user is asking. Continuing our flow, we add a form task for the follow-up question. This form allows users to see the response of their question and provide additional context or inquire further. Each of the form tasks requires us to add few buttons. We'll include two buttons, submit and cancel, allowing users to submit their queries or exit the workflow. We'll also bind the data to the form. The question on the health plan text field is bound to the input question that was sent to the get answer from document task bot. And the same bot's response text, the bot's response text field is bound to the GPT response output from that same task bot. At this point, we need to consider what happens when a user asks a follow-up question on the response form and clicks submit. To handle this, we'll add if-else pair to the flow. We'll set up a string condition on the if node to check which button of the show response was clicked. The meta property of the form task can provide interaction related values. We'll use the meta property status and compare it against cancel to check if cancel was clicked. If cancel was clicked, the process is complete. No need to do anything. Additionally, we add an else-if condition to check if follow-up question is not empty. If it's not, we'll direct the flow to get answer from document bot task using go to endpoint where target task is the bot task, and we override the question parameter of the bot task with follow-up question that was set in the response form. Additionally, we add an else-if condition to check if the follow-up question is empty or not. If it's not empty, we'll direct the flow to get answer from the document task bot using go to endpoint, where the target task is get answer from the document task bot. And we are going to override the question parameter of the bot task with follow-up question that was set in the response form. If the follow-up question was empty, the user has accidentally clicked on submit. Then we need to redirect the user to the same form to update the follow-up question so as to continue the Q&A cycle. Now that our process flow is ready, we can run it. When executed, you will see health plan input form, which provides a text box for the initial question. Let's enter our first question. Provide me a summary of Northwind Health Plus plan benefits. As expected, the bot provides a detailed summary of the plan in its response. Next, we can ask a follow-up question like, what are the maternity benefits covered in the plan? And click submit. The bot seamlessly provides a relevant response, just as we have seen before. If we decide to cancel the conversation, the cancel button allows us to gracefully exit the workflow. However, what's impressive is that the automation copilot maintains a history of the conversation, which we can revisit anytime. This concludes our end-to-end implementation of the information retrieval system. We have not only created a powerful bot, but also integrated it into an accessible, user-friendly digital assistant using Automation Copilot. As we wrap up this exploration of information retrieval pipeline, let's recap some key takeaways. We have learned how to overcome the limitations of passing a massive document to language models by implementing a structured pipeline. We explored text splitter, vector transformer, and its database semantic search tool, query tool with prompt templates. These building blocks collectively form the information retrieval pipeline, and they are the game changer for leveraging AI in knowledge extraction. Imagine deploying this pipeline in research institutions to quickly access relevant information from vast libraries of academic papers. It can be a boon for scientists and researchers worldwide. Or think about its application in customer support. A well-constructed information retrieval pipeline can help support agents provide faster and more accurate solutions to the customer inquiries. And in education, the technology could revolutionize the way students access and learn from textbook and reference materials. It's like having a personal tutor with access to the entire library. As we conclude this video, remember that the information retrieval pipeline is the testament to the power of AI and its potential to simplify the complex tasks. Whether it's for research, customer service, or education, this technology is reshaping the way we interact with information. If you found this video informative and inspiring, please give it a like and subscribe for more tech insights. Your support motivates us and keeps us bringing cutting edge content. Thank you for joining us today. And remember to stay curious and keep exploring the ever evolving world of AI. We'll see you in the next video. Thank you.